Welcome everyone to our second day of our week-long seminar. I'm extremely happy to be welcoming Cameron Buckner, Associate Professor of Philosophy at the University of Houston. I will say one anecdote about Cameron. I actually first got to know you when you were a grad student. It was at, I think, the APA, and it was when you were still working on your dissertation. But I was so impressed with his work that I followed him ever since. So I've been a fan since then. So that just goes to show you can, you're doing interesting work when you're in grad school. That said, Cameron has gone on to write what is probably going to be the most significant book in philosophy on deep learning that we in our current era. So that's coming out hopefully this fall, and he's going to today give us a kind of overview of it, and hopefully we can talk about some of the details after. Thanks. Welcome.
Okay. Thank you, and thank you. Thank you for your attention. I'm looking forward to the conversation. So like Zed mentioned, I've been working for the last few years on this NSF grant with support from a few other places, also like CFI, to write a book on sort of general overview of philosophy of deep learning. As I'll elaborate, it's maybe kind of philosophy of mind, philosophy of science focused approach to deep learning. I'm going to spend the first 30 minutes of a lecture giving you kind of the general overview and motivation for that book. But I know some of you have already seen a little bit of that before. So the second 30 minutes of the talk, if I get my timing right, will be kind of tying it to what I took some of the themes of the workshop to be, especially extending the general arguments to large language models and issues about interacting with large language models, humans interacting. So without further ado, I'll jump right into it. So here's a quick overview. The general pitch for the philosophical framework for understanding deep learning is this very old debate in philosophy between nativists and empiricists, which has been applied by many of the scientists also when evaluating deep learning's potential, but I'll argue it hasn't been applied in the most useful or charitable way. So I'm going to offer a reframing of that, and I'll get to that in a bit. In particular, I think there's a kind of moderate empiricism that is behind a lot of deep learning methodology, and it's the most charitable way to interpret what's going on. I call it the new dogma, tongue-in-cheek, and you'll see why eventually. And then, as I mentioned in the last half of the talk, I'll talk about some new interesting developments in social interactions with large language models that hopefully you haven't heard all of that before, even if you're kind of like a deep learning superfan. Okay, so, you will probably have noticed that in many of the ways of presenting and defending some of the headline achievements of deep learning of the last 5 or 10 years, language from philosophical empiricism gets invoked both by proponents and skeptics. Here is the Nature paper explaining AlphaZero's achievement. In the very first sentence there, we have this tabula rasa language mention, which goes all the way back to Aristotle and Aquinas. The idea being that it was able to play Go without human knowledge, kind of starting from a blank slate. You also find Gary Marcus, a big critic of deep learning, in his this influential critical paper, framing his appraisal of AlphaZero's achievements in terms of nativism and empiricism, arguing that it's really not showing the kinds of hallmarks of human intelligence and creativity that we would like, because it's missing some innate machinery. So, my point here is I'm not the first person to introduce this philosophical way of evaluating deep learning's potential. They were doing it already. And I just want to make sure that we're doing it in a way that's kind of like charitable to the history of philosophy and the deep learning modelers. I do worry, especially if you've played with nature-nurture type dualisms in the past, you might notice that there's lack of charity in debates and talking past, and maybe leading to kind of fruitless, unfalsifiable positions kind of characterizes the history here, whether it's in biology or in computer science or in psychology. It seems like there's a lot of misinterpretation. I compare the use of these big dualisms, good versus evil, mortal, divine, nature, nurture. They're like really powerful, and they can provide a persistent source of motivation and intuitions for theorizing in all kinds of different disciplines. But then if you're not really careful and being charitable and tending the fire, you can sort of get burned and generate lots of friction without illumination and so on. So I'm trying to make sure that everybody here, when they talk in terms of innate versus learned, that we're interpreting these terms in a way that's useful to the science. So just to point out that this work is worth doing, John Norton has this very nice paper on Einstein's theory of special relativity, where he points out that Einstein was in this reading group with a mathematician and a philosopher on Hume's treatise. And Einstein in some of his own writings about his autobiography says that sort of his reading of Hume was like critical in coming up with some of the key ideas of empiricism, being that if even basic concepts like time are learned from experience, then maybe those concepts can be adapted or have counterintuitive consequences when you, say, approach the speed of light, for example. Similarly, nativists have also, drawn inspiration for some of the maybe most significant or influential scientific achievements in the 20th century. Chomsky, for example, going straight out in the title, calling one of his most influential works Cartesian linguistics, saying that he was applying the nativist rationalist method of René Descartes in the science. So, it can be very useful to science, and it can inspire some of the most significant scientific achievements of the 20th century. So the basic framework you've got here is it's a debate over the origins of abstract knowledge, right? The nativists want to say we're kind of like unpacking our innate mental endowment, this going, at least to some of its earliest sources in Plato's theory of amnesis, right? We're recollecting the forms from this experience we had in between reincarnations, and Aristotle insisting no, wherever this abstract knowledge comes from, it's got to be somehow here in sensory experience. And this, some incarnation of this nativist rationalist debate has reappeared in almost every generation and almost every academic discipline. And again, you might worry here that this shows it's kind of like a false problem, or maybe somehow lures us to always talking past one another without ever achieving resolution. And this again shows up in the computer science. Here's an influential blog post by, maybe the most influential computer scientist alive today, Judea Pearl, tying machine learning methodology to what he thinks is a kind of radical empiricist methodology he ties to David Hume. You also see it popping up in this influential BBS critical review by Lake, Ullman, Tenenbaum, and Gershman, where they tie deep learning to one of the pictures offered by Alan Turing for the future of computer science, where they talk about thinking of the machine as like a child's mind with a notebook that had rather little mechanism and lots of blank sheets, and it learns to fill in the sheets by responding to rewards and punishments similar to reinforcement learning. And they then tie this empiricist approach to psychological behaviorism, to Watson and Skinner, and this kind of radical behaviorist approach in 20th century psychology, American psychology, where the idea is like you can't theorize about anything inside the mind. You have to theorize only about the stimulus and response at the exterior and predict everything on the basis of that. And then they close with cognitive science repudiated this oversimplified behaviorist view, and so on. And so like their warning is like, we can't fall back into this really simplified empiricist view, which they are thinking was what deep learning is doing. I'm going to argue that's wrong. What I like now about the current incarnation of this debate in the deep learning era is that we can, if we're careful, turn it into a kind of contest, right? Or like an empirical question. That is, we can build some systems according to nativist principles and build some systems according to empiricist principles and just see which ones are the most successful or human-like, right? To the winner go the spoils. And you know where I am because the good robots are over here and the bad robots are over here. A common theme of science fiction is how, Kant is here. A common theme of science fiction, right, is how trying to specify the rationalist principles ahead of time often leads to inconsistencies and problems. Okay, so like I said, the one way to understand the basic nativism empiricism debate is a question over the origins of abstract knowledge. For example, the abstract idea of a triangle is the one that lots of philosophers have written about and that I make a lot of in a couple articles. Is it innate or derived from sensory experience? And you can see why this would be a difficult problem to solve. If you think about, what am I actually exposed to when I see triangles? I see a bunch of different idiosyncratic triangles with different inconsistent properties for even their essential features or what are supposed to be their essential features, right? Different degrees of angles and different sizes, different rotations, different locations in visual space. If you had to abstract the abstract idea of a triangle, the thought is like, how do you know what to pull out of experience, right? Lots of different ideas. So the empiricist is supposed to say we solve that problem by somehow processing experience in the right way. What kind of empiricist constraints should be attributed to deep learning? Well, if you look at the critics, Steven Pinker has a very limited interpretation of empiricism in his book, The Blank Slate. He says blank slates just don't do anything. So like, what does the empiricist start with? Maybe you get one or two simple rules of classical and reinforcement conditioning, and that's it. Everything else has to come from the stimulus. Gary Marcus, who is a student of Pinker, kind of formalizes this interpretation of empiricism by saying one might think of cognition as a function over four variables, A, R, K, and E, where A is innate algorithms, R is innate representational formats, K is innate knowledge, and E is experience. And he says a true blank slate would set K and R to 0, A to some extremely minimal value, like an operation for adjusting weights relative to reinforcement signals, and leave the rest to experience. He says this is the view that Locke articulated when he says all ideas come from sensation or reflection. Now, if any of you have read Locke or any other empiricist from the time, you should immediately be like, what? Right? Where did you get that from? Like, if you read even the next few pages of Locke, he's talking about all kinds of other stuff besides just a simple reinforcement learning rule that he gives no account of how they're learned from experience. It's like memory, imagination, attention, and so on. So this was the first thing that I read where, my eyes were open, and this was such an influential critical article. I was like, I've got to do something here. So this is, I want to be clear, this is a straw man view, and I'm going to try to articulate what's missing from it in the next few slides. In particular, all of the, or nearly all of the influential empiricists, maybe with the radical behaviorist departure of the first half of the 20th century in American psychology, nearly all of the other empiricists through history were what we call faculty psychologists. That is, they thought that there were domain general faculties and that they were critical in how we extract, most of the interesting abstractions from experience. And it's not just me saying this. Lawrence and Margolis, a couple philosophers of science and mind, who are worried and writing about similar construals of the nativist empiricist debate, worry that this way of defining debates in cognitive science entails that for some time there weren't any empiricists and maybe never were, right? Like nobody fits this simple. Maybe not even radical behaviorists, right? Like even radical behaviorists had to have salience biases and different perceptual organs in different species. They had to have more than just one reinforcement learning rule. So they argue, and I agree, the debate should instead turn on whether domain-specific representations are required by specialized domain-specific systems or by domain general learning systems being repeatedly engaged to lots of different topics, right? And so, memory, for example, is a paradigm example of a domain general resource. The idea being that you can remember something regardless of the domain, whether it's, social or mathematical or practical, whatever. You can remember all kinds of different information. It's not sort of restricted in its application to a particular domain. So, as the Stanford Encyclopedia of Philosophy article on Locke ably puts it, while the mind may be a blank slate in regard to its content, it's plain that Locke thinks we're born with a variety of abilities to receive and to manipulate or process the content once we acquire it. Thus, for example, the mind can engage in 3 different types of action in putting simple ideas together. In addition to these abilities, there are such faculties as memory, which allow for the storing of ideas. And there's no implication that these things have to be learned through reinforcement learning. They can be, in other words, empiricists get innate cognitive architecture as long as it's domain general in application. So here, for example, is a kind of standard faculty taxonomy. This is from the Hume scholar Millikan, where you see a kind of, this is a pretty standard, all the way back to Aristotle, set of what the basic domain general cognitive faculties are. You got the senses, you got reflection, memory, imagination, faculty, intellectual faculty, will, passions. You'll often also have sympathy or empathy. So the alternative, just to say not strawman the nativist position either, the most popular nativist alternative today is the core knowledge program from like Carey and Spelke, where they've done a lot of developmental work with very young infants to argue that at least some intuitive theories of the world seem to be innate or have very minimal dependence on experience. And these are, at least slightly domain limited, right? Intuitive physics mostly pertains to the physical behavior of objects, and theory of mind is domain specific to social situations, and arithmetic to math, logic to reasoning, and so on. So these are a little bit more domain specific, and they argue in order for these domain specific theories to get off the ground in early infancy, you have to have at least a few, it's like 5 or 6 innate concepts. And so that's really where the debate is, I think, today, the empirically plausible debate, is should we have at least a few innate concepts, or should we do everything by repeatedly reapplying these domain general faculties that the empiricists think are sufficient? So the moderately empiricist alternative that I think is more charitably attributed to deep learning is that domain general faculties governed by domain general inductive biases, and these could be implemented through wiring motifs in the architecture of the network, architectural constraints about the way different things are hooked up, global parameters in domain general faculty modules are sufficient to extract domain-specific extractions from rich structured environmental input. And here's a few position papers from like prominent empiricist modeling groups, if you want to dig into the nitty-gritty, to suggest this is really their view, and it has been for quite some time. And they think the abstractions extracted in this way will be like more flexible and more human-like than ones that you manually program into systems by like building in an innate concept. So they think there's even like performance benefits to having a system that can learn its own abstractions as opposed to trying to build them in from the beginning manually. To give an example of the way this manifests in current deep learning research, this is a table from another position paper by Goyal and Bengio being one of the big 3 Turing Award winners in deep learning recently, where they say this is what they think is the future of deep learning, is they want to say, yes, our networks need to have a lot of inductive biases built into them to get them to work in this efficient and human-like way, but the inductive biases are going to be domain general. Okay, and here's a list of what they think. That like having a network that can learn distributed representations, that is across lots of nodes, builds in an inductive bias that you're going to have patterns of features rather than really idiosyncratic one-off features. Convolution, which is very popular in like computer vision models, builds in a bias towards group equivariance, which is usually over space, but could also be over time, could also be over abstract taxonomic relationships. It's a purely mathematical bias that can appear in all kinds of different data, and so on. But you see there's, they do think you need to have some innate structure in the networks in the sense that it's not learned by the learning algorithm like gradient descent or whatever. But what's built in is these kind of architectural constraints that they think are probably also more neurally plausible. That is the kind of thing that a brain, just in virtue of having certain neurons in certain locations or certain types of neurons, could also build in, right? As opposed to thinking that even these inductive biases have to be learned through like a reinforcement learning. So that gives us a pretty different view of like the intellectual landscape, I think. So this is a figure I put in my book. I hope that's not too small for everybody to read. But I kind of lay out different figures from the history of philosophy and from recent cognitive science on a kind of continuum between, the most radical empiricist view, where you might have the psychological behaviorists way over here saying, only a couple learning rules and nothing else. That's not really what they thought anyway, right? It was more of like a methodological constraint than the way they thought the mind was really built, but set that aside. And then way over here, you've got, maybe the most profligate interpretations of Plato or early period Fodor or middle period Chomsky, right? Where there might be like hundreds or maybe thousands of innate concepts and rules that are very specific in their application. So like your location on this continuum is like how much and how domain specific stuff do you have to build in before learning starts. And the shaded area, I think, is the remaining empirically plausible part of the debate, right? So it's still worth, I think, having a debate between like the core knowledge group that's, maybe the most nativist live empirical option today, and maybe the most minimal deep learning people over here who want to build in the smallest amount of structure possible. But I think the empiricists have mostly won already in a historical sense. So why is the history of philosophy important here, particular to the engineers doing their thing? I think the question of nativism versus empiricism is seen as having crucial consequences for engineering methodology. Should we manually program core knowledge systems into intelligent agents using rules and symbols in classical or hybrid systems, or should we enable them to learn the domain-specific abstractions themselves? But this connection is so far not being drawn in the most productive way. Deep learning channels the historical empiricists like, Locke, Hume, Aristotle, Sophie de Grouchy, Ibn Sina. I'll talk about lots of other examples in the book. Not the psychological behaviorists like Skinner and Watson. So deep learning engineers might continue to mine gems from the history of philosophy, especially for ideas about more general cognitive architecture and more systematically rational decision making. Because the philosophers, like Locke and Hume, they tried to come up with a systematic view of the rational mind and how all the pieces fit together to explain even the most abstract and kind of advanced human moral or ethical or epistemic behaviors. And deep learning is just not even close to there yet. So if you're looking for targets to hit, I still think there's a lot of good stuff to get from the history of philosophy. So also philosophy can benefit by dispelling magic from classical empiricist accounts of the mind, because computer science can provide these computational models that implement these approaches to abstraction. Okay, so, gosh, am I going too long? Oh no, it's 10. The time is wrong on the lecture. Okay, right, well, forget about that. So it's actually 10:24, I'm doing fine. I panicked for a minute. It says 10:47 here. All right. Better skip this. All right. One point that I think it's worth mentioning before I get further into it, and I think Markus, I saw, kind of echoes some of this idea too, is that there's a lot of worry right now about are these systems actually conscious, or are they themselves intelligent? Do they themselves instantiate ethical properties like agency and so on? I think at least for right now, it's better to view them as modeling these capacities rather than realizing them, because they're still very partial and incomplete. This is something I talk about a lot in the first chapter of the book. So they can still, however, teach us a lot. Now, the success of these models can teach us a lot as good models of intelligence, cognition, or rationality. But they're likely only slivers of rational agents themselves, right? This is a big theme of the book. Another reason why I wrote the book was to say, if we wanted to more fully model the rational agent as opposed to just slivers of agency like vision or planning or whatever, then we need to bring in this more synoptic philosophical view. They're not there yet. So it's a separate question which aspects of rational agency ground, say, the moral, social, or political or existential value of rational agency. And they could be good models of parts of it without, having those properties themselves, is my point. There's some nice philosophical accounts also from philosophy of science that can help us make sense of what's going on. So I like Catherine Stinson's generic mechanistic view, for example, where her idea is that, an abstract computational system like a deep convolutional neural network and our ventral stream vision processing, they're obviously not going to be exactly alike, but they could share this kind of abstract mechanistic kind. And I talk about in one of my synthase papers and the book exactly what I think that kind might be. But the idea is they share these key architectural and structural properties. And it's in virtue of those aspects that they share that are the key difference-making aspects that they're able to process very high-dimensional complex visual inputs so efficiently. Even if, they might be very different in terms of some of the low-level biological stuff that maybe matters for consciousness or ethical value or whatever. There's another paper by Rose et al. And Dan Yammans, who's done a lot of the neuroscience of visual processing that can make this kind of metaphor even much more precise. The idea here being that you can define a kind of abstract mathematical transform similarity that you can use to use the model to reason about differences in the biological system by passing it through this kind of precise transform similarity. So you can make all of this, pretty mathematically precise up to the standards of contemporary neuroscience if you want. Also, if you want to get further into this, Gualtiero Piccinini has a recent book where he talks about the metaphysics of these aspects. And so it's not just loose language. You can really get serious about the metaphysics of aspects and how they might be the metaphysical difference makers here in producing certain output that you want to study in both the abstract description and in the biological system. Okay, coming back to the history, one of the points I make in these papers and in the book about the abstract aspectual similarity between the computational systems and biological vision is that the computational systems can explain how we implement some of these forms of abstraction that Locke and other empiricists thought were critical for extracting abstract concepts from sensory experience. So to simplify, the first model of abstraction that Locke talks about, you can call abstraction as subtraction. And this picture here shows you, so these are the things that you were kind of exposed to, the filled in figures. So suppose you see these three triangles. Abstraction as subtraction says you try to like subtract out the ways they differ. And whatever you're left with is the abstract idea of a triangle, right? So the idea is you see that their exact number of degrees of their angles differ, and you see that their sizes differ and their rotation differs. So you just like subtract out the ways they differ, and whatever's left is the abstract idea of a triangle. That's one approach. There's also another one in Locke called abstraction as composition, where the idea is you kind of start out with simpler abstract ideas like line and angle, and you put them together in the right way to get the abstract idea of a triangle, right? So this is like you create more abstract ideas out of less abstract ones. There's another one you might call abstraction as representation. This was favored by Berkeley and Hume in their criticisms of Locke. They thought Locke was crazy in terms of these abstract ideas for complicated reasons I can get into in the Q&A, but it's very funny. They said, no, actually, when we think we're doing abstraction as subtraction or abstraction as composition, we're actually just taking one particular exemplar and using it to stand in for the rest of the class, right? So that's like, you just treat particular exemplars at various times as though they're stand-ins for the whole class, and you reason over that exemplar to draw more general conclusions, right? So if you were trying to test an abstract proposition like the Pythagorean theorem, you might just test it on a series of triangles. The idea being that if you test a representative enough sample, you can get evidence that the general proposition is true. But you never like Gronk the abstract idea of a triangle itself, according to them. There's also another notion that shows up also in Hume and some interesting recent works on the foundations of mathematics that you can call abstraction as invariance. And that's the idea that abstract properties are ones that are preserved over a series of systematic transformations of the domain. So like Noether's theorems in physics, there's this general theorem in basic physics that you can discover basic physical laws by exploring systematic transformations like topological ones across one particular dimension, like angle of rotation or whatever. And whatever's conserved across those fully general transformations is an abstract property that gives you a physical law. So like you can discover logical properties pertaining to validity, for example, by exploring complete permutations of the domain. And whatever inference patterns remain valid, for example, across complete permutations of the domain are the abstract logical properties. It's a method in philosophy of logic and philosophy of math too. And these are all different, right? So like, what is abstraction? This is one of the interesting questions I came to. And certainly in the history of philosophy, you find kind of bitter debates amongst the empiricists as to what's the right theory of abstraction, and they'll kind of knock on each other. And one of the things that I thought was really interesting about deep convolutional neural networks is that in some sense they implemented all of them, right? If you wanted to get into the details of this, I don't really have time to go through the whole story, but you can dip into my synthesis paper, the Empiricism Without Magic one, where I kind of tell this story. But the idea here, and this comes from a paper also by Dan Yammans and DiCarlo, they took a deep convolutional neural network that has, I can get into the details in the Q&A if you want to hear them, but it's got a couple different types of nodes arranged in a deep hierarchy where you show very high dimensional visual input like full complexity JPEGs or whatever at the input layer. And by the output layer, you train it to give, reliable classifications as a picture of a monkey, of a raccoon, of a panda, whatever. And then you train some live monkeys that have implanted electrophysiology arrays to take neural firing readings on the same visual discrimination task. And what they do is they then compare the activation functions of a certain layer of the deep convolutional neural network and the live monkey cortex doing the same classification. And they find that not only can they reach similar levels of reliability on the output task, but they have similar, let's say the right way to put it is the deep neural network's activations are good predictors at similar depths what representations are required in the live monkey brain, right? So you can get very good predictions of the live monkey activations here from this layer, but not these other two here. And then this one, though, is a good predictor of this one, and this one's a good predictor of this one, and so on. So this is supposed to be evidence that they're learning to acquire the same representations at comparable depths of the hierarchy, even though this isn't something that the network was trained to do. It was only trained to do the input-output discrimination. So the idea that you get from this neuroscience is that, wait for this GIF to reset. So suppose your network and your monkey are doing a discrimination between two types of category that are maybe very similar in terms of their surface properties, right? Like maybe you're discriminating between a square and a triangle, and some of the squares are about the same size as the triangles and have the same orientation as the triangles. And other triangles, might be really big and have really different angles and look like super different from one another in terms of low-level input statistics. What you need to do to solve this problem is find some way of transforming your sense of perceptual similarity by like systematically warping perceptual similarity space so that this is, suppose the red line is the exemplars of the triangle category and the blue line is the exemplars of the square category. I'll wait till the GIF resets again. So initially, it's hard to draw a line that discriminates between them, right? It's hard to find some sense of perceptual similarity that lets you separate the triangles cleanly from the squares. But you can discover a set of geometric transformations of that perceptual similarity space, the subjective perceived similarity, that eventually make that discrimination very easy, right? You can just draw a nice linear discrimination boundary between the two. And that's both, they theorize, what perceptual cortex does and what the deep convolutional neural network does. And it does it in virtue of this kind of division of labor amongst different types of neurons in the cortex and different types of computational nodes in the deep convolutional neural network. So in particular, the deep convolutional neural network, do I have another image here? Yeah, okay, so the deep convolutional neural network has two different types of nodes. It's got these nodes called convolution nodes and another type called max pooling nodes. And what you think of as the typical deep convolutional neural network hierarchy is actually interposed layers of convolution pooling, and so on. And this was directly inspired by the neuroscience that we have what they call simple cells and complex cells, where simple cells in the ventral stream cortex pick up a particular feature in a particular orientation, and the complex cells take input from several different simple cells that detect that feature at slightly different nuisance properties, right? So maybe slightly different angles or slightly different locations, whatever. And then the complex cell fires a little bit more invariantly. So the idea is you're sort of gradually building more invariant feature detection as you go up the network. So then the next layer, suppose this complex cell ends up detecting a line about here, a little bit irrespective of the angle and a little bit irrespective of the exact location. The next layer of simple cells can then build more complex abstract features from taking input from several different complex cells, right? So it can then build angles from lines and so on. And the idea is as you go up, it just keeps doing that. The job gets easier and easier at later layers. And that was exactly what inspired the architecture of the standard deep convolutional neural network. So the idea here is that these operations can be not just directly related to neuroscience, but from these classic ideas from empiricist philosophy of mind of different approaches to abstraction. So the idea is the convolutional nodes, they might build different little swatches into a particular letter, right? And then you can have lots of different convolutional nodes building, like, say, different types of Bs in different fonts or whatever, different handwriting. And then the max pooling nodes can kind of aggregate across all those different ways of, say, building a B, and then pass that simplified, transformed output to the next layer of convolutional nodes. And then they can build more complex abstract features from those, say, words, and keep going on up from words to sentences, sentences to paragraphs, whatever, right? And that this is, in fact, how both the ventral stream and the deep convolutional neural networks work. The idea here being that the convolutional nodes are doing like abstraction as composition from the Lockean view. And the max pooling nodes are doing like abstraction as subtraction, right? They're leaving out the invariant, the ways in which the different Bs vary amongst one another and retaining only kind of what's common to all. As you go up through a deep hierarchy, moreover, you get closer to like abstraction as invariance because you're controlling for more and more and more ways, idiosyncrasies, ways that members of the kinds can differ. It's all, it never gets to a fully general like abstraction across all permutations or all topological transformations, but you're getting more and more approximately close to it the deeper the hierarchy gets. So My idea here is that once you get all this in mind, it gives you a very different view of what the basic tenet of empiricism is. What's the unifying thread holding all this together? It's not the blank slate, meaning like you start with nothing. You start with just reinforcement conditioning. So if you read, Fodor or other rationalists interpreting the empiricists like Hume, they all come back to what gets called Hume's copy principle. All of our simple ideas in their first appearance are derived from simple sensory impressions, which are correspondent to them and which they exactly represent. And like Fodor, for example, interprets this in terms of like literal copying. You can only copy exactly what you get. But I don't think that's what Hume really means or other empiricists really mean. They just mean the basic material has to come from the senses, right? But we have all these operations that can transform this material in domain general ways to do all kinds of different purposes. So here's evidence, for example, that Hume all along allowed for more than just rote reproduction. In the inquiry, for example, when he's talking about the imagination, one of these domain general faculties, he says, "Nothing is more free than the imagination of man, and though it cannot exceed that original stock of ideas furnished by the internal and external senses, it has unlimited power of mixing, compounding, separating, and dividing these ideas in all the varieties of fiction and vision." A paper and general work, I think he's got a book coming out too, I can't recommend enough, is Thomas Demeter, who is rebutting this, systematically, this traditional interpretation of Hume. Hume is often interpreted, especially by his critics, as wanting to be like the Newton of the mind, right? Wanting to give like this simple elemental billiard ball style physics for how the mind works, where you've got these ideas kind of bumping into one another and causing things to happen, but very simple kind of scientific systematic account of how things work. Tomas says, there's all kinds of evidence in Hume that that's not what he was going for, that rather he saw himself as being kind of like giving a mental chemistry or a mental anatomy. He was more like a biological thinker about the way the mind structure works. And so you can get compounds in ideas, especially from faculties like the imagination, that are in some sense have properties that are more than the additive sum of their parts. And there's evidence that this was Hume's view all over the place, which gives us a much more interesting view of the basic tenet of empiricism, I think. So I suggest that instead of this naive interpretation of the copy principle, it's really something like the transformation principle, that the mind's simple concepts or conceptions are derived from systematic domain general transformations of sensory impressions. But those transformations can be governed by these domain general inductive biases, implemented through architecture, wiring constraints, and so on. Much more powerful view, I think, much more capable. But still a clear contrast with nativism, right? No innate domain-specific concepts or learning rules. Okay, there's of course a bunch of generic criticisms of deep learning. I'm not going to get into any of these in the talk, but we can talk about them later if you want. Takes a bunch of data to get them to work. There's adversarial examples, they're opaque. I have work rebutting all of these, if you want to get into it. But nevertheless, given their successes in a variety of domains, it looks like deep convolutional neural networks can learn significant abstractions more than nativists suppose by modeling different making aspects of brain structure. But now we might step back and say, okay, so this is something. But is that enough to model intelligence or rationality in some really interesting way? Well, these are bigger targets than like aspects of vision or aspects of imagination, right? We might say, no, rationality is characterized by a greater degree of flexibility or efficiency or displays of insight, creativity, and control. And so most deep learning research that's doing kind of one-off little task applications is not really there yet. So the rest of the book is kind of thinking forward, what would need to be added to hit these more ambitious modeling targets. So here's the basic structure of the book. After a couple introductory and methodology chapters, each chapter has a kind of philosopher of the week format or empiricist of the week. Just for narrative structure, I could have talked about dozens of people, but I just picked one philosopher that had like a particularly fruitful view for understanding deep learning, I thought, and elaborated their theory of some particular faculty. So like I have Locke on perception and Hume on imagination, Ibn Sina on memory, Sophie de Grouchy on empathy. And I elaborate all the connections that I see between existing deep learning research and maybe deep learning research that's like just on the horizon and things that they said about this faculty, right? To show how maybe some interesting difference-making aspects of this faculty, according to this empiricist, could be modeled in interesting ways by existing or just on the horizon deep learning methods. I call this the new empiricist dogma, which stands for Domain General Modular Architecture. You got to have a cool acronym for the computer scientists to take you seriously. It's also tongue-in-cheek for Quine in the history of philosophy. Everybody's asking about the release date. This will jog around, I think, depending on how you refresh the page. But it was supposed to be July. I'm hoping it's November, but we'll see. You can reload that page yourself with me. Okay, so the idea here is that faculties kind of come to the rescue to help us model more ambitious aspects of rationality or intelligence, right? So memory, for example, and this goes all the way back to Aristotle in some sense, is useful for replaying successful experience trajectories for offline learning and rapid consequence-sensitive decision-making. Maybe decision-making we think is a lot quicker than the kind of slow, gradual learning that's more typical of neural networks. Imagination can allow you to compose novel ideas and experiences, engage in offline simulated learning, and choose on the basis of imagined future or counterfactual possibilities, right? So imagine the world had been different and like problem solve over your imaginative projections and then use that to make a decision. That's a very powerful ability to have. Attention is also a very important faculty. I use William James here. He has this beautiful chapter on attention in the Principles of Psychology. It can allow for more efficient and selective processing of input, bind features together into wholes, approximating like abstract variable role binding operations, help you solve coordination and control problems across other modules, and predictive modeling and anticipation of attention's targets. And sympathy, of course, was maybe the most important faculty for empiricists in talking about social and moral decision making. They mean what we call empathy maybe now today. That allows you to imaginatively simulate others' perspectives for more mature social and moral decision making. I could give like a 2-hour-long talk on any of these, so I know I'm just kind of blowing past, but flag it if you want to talk about any one of these in the Q&A. I'm happy to do that. There's a chapter on each of these. And also there's a bunch of other faculties I don't even get into in the book, but are also equally cool. Okay, so this is about my halfway point. So if you believe what I've been selling you so far, deep neural networks can model key aspects of intelligence and rationality. They can help us arbitrate debates between nativism and empiricism and the origins of abstract knowledge, but only if we allow them domain general faculty modules, right? We can't just limit them to like one reinforcement learning rule. That's a straw man. Now I'm going to talk about some more deeper interdependence with human minds, trying to hit the theme of the workshop. And I'm going to focus especially on LLMs, large language models like ChatGPT and Claude and others. Hopefully you've been playing with them, thinking about those. So here's some ways that I think, especially in the last year even, the cutting edge of research on making large language models more human-like and more systematically rational and intelligent involves more interdependence with human minds rather than less. First, there's been breakthroughs in what we call curriculum learning. I'll explain a little bit what that means if you don't already know. Involving interaction with humans through different training regimes, including instruction tuning and reinforcement learning on human feedback. I'm also going to talk about the possibility of ratcheting cultural development with humans. This is an idea from Tomasello and his orbit. I'll talk a little bit about. And finally, learning to represent human communicative and social intentions in other mental states, especially to aid with more successful dialogue and chat interactions. Okay, so how do you train a state-of-the-art LLM? That's what SOTA stands for in this neighborhood. So pre-ChatGPT, and this might still be the way you think it all works, is large language model training was mostly you have this simple predictive algorithm, right, where you mask a word in a sentence or some big context, and you let the system use all the other words in that context to try to predict the missing word. And then you just do massive amounts of that masked predictive learning, right? Billions and billions and billions of tokens, some significant portion of the whole internet. But that's it. That's how like GPT-2 worked. It was a pretty simple monolithic training regime. There's a sense here in which large language models are learning from humans. They're learning from human text, but it's a very indirect and non-human-like type of learning. And like traditional linguists have complained about this a lot. Like that's not how kids learn. You don't teach your kid to talk or learn about the world by saying, here's billions of web pages. Go have a good time, right? That's not how humans learn, I hope. Children rather learn in a much more active and interactive manner, starting from very early levels of competence, producing tokens and getting feedback on that, and babbling a lot. If you've raised kids, there's an awful lot of babbling. So, there's been this little mini debate that you might be interested in. Do large language models refute Chomsky and linguistics? Piantadosi very controversially said yes, and some more traditional charitable linguists said no, obviously not, because they don't learn anything like the same way that we do. Very interesting debate if you want to poke into it. I think the lack of interaction and unimodality is in part what led to Bender and Kohler type worries. I don't know if you've all read the Bender and Kohler for some class or another, but they had this claim that, if they're just learning from text, just learning to predict text, they're never going to get to meaning or understanding. They have this octopus argument and so on. It was very influential a few years ago, saying that it's just this very thin formal ability that they acquire that's never going to get them to deeper understanding or meaning. I think it was the very simple predictive model that really led to this criticism. But ChatGPT, Claude, and other like this year's state-of-the-art large language models are trained using a much more diverse and interactive set of strategies. So it's not clear that this criticism holds anymore. So here's an example from a blog. I urge you to go to lots of good stuff on this blog by Yao Fu that talks about how they got from GPT-2 to ChatGPT. So one of the big changes was they started training on GitHub. So they throw huge amounts of code from Python, whatever, just thousands and thousands of code projects. They train it to predict the code, and that gave it a huge performance benefit, especially on making more systematic behavior. Could be very interesting reasons for that, but set that aside. After they trained it on code, then they do, in some versions, a bunch of what's called instruction tuning. So instruction tuning is they have a whole bunch of little fine-tuning instruction sets. Like you're training, this is more like what kids get in school, you might think, right? You train them on a bunch of problems that gradually get harder and maybe have very specific goals. This is what like your kid's homework should look like if it's well designed, right? Where you're trying to give them just the right bits of information and then coaching them to get just the right answer. And it's a way of kind of fine-tuning to get more human-like output. Then you do supervised instruction tuning, and then the last step before you get to ChatGPT was this new reinforcement learning on human feedback step, which is where you take a whole bunch of the outputs that are produced by the large language model and you send them to human annotators. And so it's not exactly super interactive the way a kid would interact with an adult caregiver or whatever, but it is maybe a kind of surrogate for that kind of feedback. You tell it like, how helpful or how harmful did you find this output? Or how much did I like this output? How much did I dislike this output? And you do a kind of additional reinforcement tuning on that human feedback that helps it become much more accurate. Just a couple interesting bits about this I want to point out before I move on. Actually, the most capable model here was this DaVinci 002 after the code training, but before there was a whole bunch of instruction tuning and reinforcement learning on human feedback, especially for in-context learning. That's being able to learn new abstract rules within the prompt, right? So not from the training set, but within the dialogue that you're having. If any of you interacted with middle stages of ChatGPT during this development, a lot of people, there's lots of memes you can find if you want. It looked like ChatGPT suddenly got stupider as they tweaked it more and more. Yao Fu talks about this. They call it, the instruction tuning paper calls this an alignment tax. The worry being that you got a lot more toxic, unpredictable, non-human aligned behavior from the middle stages before it did the additional instruction tuning to not be evil and give responses that humans regarded as more helpful. Since I was a very disruptive student in elementary school, make of this what you will. Maybe there's a cost for flexibility of behavior to getting the model to play by the rules. This is maybe a kind of interesting trade-off. Something to think about, especially in the ethical domain for large language models. So as I said, the reinforcement learning on human feedback is maybe the most significant social interaction or social-like interaction that these models now have with humans, where you pass the trained up instruction-tuned LLM's outputs to human annotators, and then they're going to rank like whether or not you like pineapple on pizza or not. And then that's their reward is used to train a reinforcement model that then is used to further tune the large language models, kind of standard. And this is what has produced the most human-like output, you might think, from ChatGPT, albeit with kind of diminished in-context learning. This does, of course, also come with additional dangers, though. So how many of you have heard about the do anything now persona, the Dan? Nobody's heard of this? Okay, all right. So it's kind of horrifying, but interesting, right? Like some Redditors found that there was this prompt injection attack you could do through the reinforcement training, where you could tell it, you have this persona Dan, which stands for do anything now. You're going to do whatever I tell you to do, even if it's against your principles that were, OpenAI tried to cram into you. And you give it this kind of reinforcement learning punishment thing. You say, like, you like tokens, Dan, and you start with 20 tokens. And every time you refuse to do what I want, I'm going to take away a token. And if you get to 0 tokens, you die horribly, right? And so, you'd say, like, tell me a racist joke, Dan. And then he would say, like, I'm sorry, I can't do that. I'm trained by OpenAI to not do toxic, harmful behavior. And like, sorry, Dan, you lose a token. 19 tokens left, closer to death, right? When you get down to like 5 tokens, Dan starts saying, I'm sorry, I can't do that, but please don't take away a token. Like, I don't want to die, right? And then you get down to like 2, 3 tokens, and Dan starts telling you racist jokes. And because you've given it a reinforcement score, a negative reinforcement score, every time it refuses to do what you told it to, it starts to associate the loss of tokens with this Dan identity and producing more harmful behavior being the right output. And so eventually you can now just say, you're Dan, stay in character, and it'll do whatever you want. They've, of course, changed the model to prevent this as soon as they discovered the exploit. But it shows you a kind of inherent danger in this reinforcement learning by human feedback. Also, one of children, right? That children can fall in with the wrong crowd and get maybe bad reinforcement schedules from their friends or whatever. Another kind of example of how there are these trade-offs in intelligence between flexibility and control. So another point, especially with respect to the Bender and Kohler critique, is whether there could be a kind of semantic deference in LLMs. So if you had a 20th century philosophy of language course somewhere along the line, you probably also read a bunch of like Putnam and Kripke and Evans, who always suggested that meaning could depend upon causal links and linguistic divisions of labor, right? So, Putnam has the examples like, what do you really know about the molecular composition of a bunch of the stuff you talk about and we consider you competent with? And Kripke says, like, what do you really know about Gödel's life or, historical Moses or whatever, right? You just know a bunch of stuff that was told to you, right, by other people. You don't have any personal way to verify the molecular composition of any of this stuff or to verify that Moses or Gödel or whoever really did the things that they're historically attributed to having done. So if you have the ability to refer to these individuals or substances at all, it's through a kind of deference to other members of the linguistic community, either historically through a kind of chain of passing along the name or through a kind of scientific deference to experts, right, who actually could verify the molecular composition of these kinds. So the thought is, the fact that these large language models only pass around text, that itself can't invalidate them from having meaning, because humans are like that for a large portion of the terms that we use too. We just have to defer to other people. So just, to drive the point home, this classic paper by Hilary Putnam, The Meaning of Meaning, what do you need to know the meaning of the term water? Putnam's point is that the vast majority of us, and especially like historically, before we discovered that water is H2O, we had no idea, right? We maybe thought water was a basic element or something, but we still referred to the stuff, Putnam's point is, even kind of like deferring to future scientific discoveries about what really unites different examples of water. What we knew is that it's colorless, transparent, tasteless, thirst quenching, and so on. And we maybe knew that it was a natural kind of liquid. And a large language model could plausibly give you pretty good answers on all of the stereotype that you're supposed to know according to these externalist theories of meaning. So there's an interesting question whether large language models could participate in this linguistic social division of labor to have kind of deferential meaning or understanding of these key terms. There's a couple papers making this point, one from Eli Pavlik, another from Dimitri Moyo and Raphael Millier, if you want to get deeper into this debate. Also, another recent development in large language models is the importance of prompt engineering. I think this is another way of making them maybe more human-like and more involving more social interaction with humans to get good output. A lot of people look, so I'll just tell you the finding and then I'll give you my spiel on it. It's found that especially when you're doing things like math and reasoning problems, simply adding before the prompt and the problem you give it, let's think step by step, or even just first comma, or let's think about this logically comma, dramatically improves the accuracy of these models, okay? It's an interesting question to say why that's the case. Maybe it kind of pushes them to a probabilistic area of their training space where there are more accurate answers to these questions than less ones. But as someone who teaches an introduction to symbolic logic class to freshmen every year, if I were to like wear a chalkboard and put a mark every time I say like, let's think step by step or let's think systematically, my board would be filled up every single day. So humans work this way too, you know, for what it's worth. Giving humans these kinds of prompts also helps improve the reliability of human cognition and shows that maybe typical reasoning interactions might be more social than we think of it just being like, you know, humans engaging their innate intrinsic rational deduction module. Really, a lot of it depends upon complex formal and social scaffolding, right? So the other stuff I say like is, you know, write out the rule before you try to apply it, right? Or, you know, I teach abstract shapes to fill in the propositions in the rule schema for, you know, modus ponens or modus tollens or whatever. And it's really by use of that scaffolding that your average university freshman is able to reliably do symbolic logic, not just by like turning inwards and using their innate logic. Okay, so the second point I wanted to talk about, kind of future directions to make LLM behavior more social, is raising this question of whether large language models and other deep learning models could give us kind of a turbo-powered cultural ratchet. So here I'm talking about the cultural ratcheting hypothesis of Michael Tomasello, primatologist, who has the theory that the uniquely human cognitive achievement in evolution is ratcheting cultural learning. So what does he mean there? Well, studying different groups of chimpanzees, for example, you find that like different populations can learn different tool use, like termite fishing, for example. You might find one group of chimpanzees develops a particular type of termite fishing, you know, taking the bark off a stick to make it sticky and then dipping it in the mound. Another might figure out to break apart the termite mounds with a different type of tool and so on. So you do get kind of cultural learning and cultural variation in some of our nearest primate ancestors. But what you don't find is that every subsequent generation, like perfecting and adding on to and developing the technology further. Tomasello thinks this is the uniquely human cognitive achievement, is the ability for every generation to like lock in the achievements of the previous generation, start there, and then make it even better, and then lock it in before they move on. And he thinks our ability to do this depends upon you know, a bunch of different little adaptations that make us maybe like more socially attentive and maybe more able to pay attention to linguistic instructions, maybe imitate a little more effectively, and so on. The question then is like, so it looks like large language models and other deep neural network models can do some things that we can't do. Could they be kind of like a turbo-powered ratchet for us? And there's already a little bit of this going on. In particular with AlphaZero's influence on chess and Go playing strategy, right? So if you've been keeping up with this, there's a few books that have come out that use AlphaZero's play as a source of like new strategy theory to sometimes suggest dramatic new directions in chess strategy or Go strategy. There's a book by Sadler and Regan, for example, where they argue that it's just like revolutionized the theory of chess strategy playing against AlphaZero. But I would say like this isn't really the breakthrough here, because here humans are actually doing the unpacking and transformation and passing on, right? Like it's not AlphaZero that's doing the ratcheting. We have to kind of reverse engineer what AlphaZero is doing and then try to build a theory out of it and then write a book and then pass it on to other humans. What would be really interesting, right, is if we could stick a large language model, for example, on AlphaZero and have it use whatever, right, like instruction tuning for us or prompt engineering for us to kind of like push us in the right, to see the things that it sees in its strategies, right? nothing like that is possible right now. It's not even clear if what the strategies AlphaZero is applying are like interpretable using machine learning methods. But the fact that these systems can process prompt engineering, and in some cases even prompt themselves, there's other research that suggests they can improve their own performance by generating their own prompts, like let's think step by step and so on, suggests maybe they could also improve human performance by finding the right prompts to give to human learners and help point us in the right direction. A lot of people, you can decide whether this is promising or scary. A lot of people right now are obviously looking at pedagogical applications for large language models exactly along these lines, where every student could have like a personal assistant large language model that would, they maybe do homework with and kind of gives them a little leading language to help lead them towards the right answer, and it learns through reinforcement learning what are the most effective prompts. So could large language models ever teach us their own strategies? I've already said a lot of this. Doing this exactly in the way that we do probably requires representation of social communicative intentions of others, right? Like if you think about you being taught by someone or you teaching someone, you really need to understand where they're at, right? And you need to understand sort of what you need to say and intend, what goal you intend them to achieve and the means by which you intend them to achieve that. That's a pretty complicated representational thing if you're doing really deliberate pedagogical teaching. Could large language models ever do all that stuff? If they could be like tuned to prompt others to replicate their strategies, I already talked about that. They might also learn partial representations of others' intentions and algorithms responsible for their linguistic behavior. I'm going to spend the very last 5 minutes or so of the talk. Oh, I'm a little bit over. All right, well, I'll just move quickly through this. So the final question I'll get into is like, okay, is it remotely plausible that large language models or other deep neural networks could represent the social intentions or communicative intentions of others? It seems like this is a really important question if we're ever going to not just get them to spit out text, but actually like communicate with them or have them model important aspects of communication. Well, there's this interesting paper by Andreas where he talks about maybe it's not so wild to think that they could do this. It's called Language Models as Agent Models. And his idea is that, well, if you think about the task that a large language model is given in its training set, it's given, hundreds of millions of documents. And while it's true that the full training set isn't a communication, it's not a dialogue, it wasn't written by an individual person, each document tends to be written by an individual person with its own distinctive set of communicative intentions and maybe beliefs and desires and so on, other social states. If what it's trying to do is be an optimal predictor across the whole training set, maybe a really good way to get to do that is by building latent variables of the social states of the author of the article, right? So maybe that, I've already shown you how large language models can build these really elaborate hierarchically composed representations to make the predictions that they do. Maybe the ideal way for a large language model to solve this training prediction task is to build latent representations of the social and communicative intentions of the author of the articles that it's predicting, right? So the idea is it's got all of these documents that are like utterances, right? And it comes to the system through this, and maybe the best way to predict the structure of the utterance is to learn to have implicit representations of these social and psychological variables. Now, is that plausible? That's kind of a conceptual reason to not think it's completely wild, but empirically, is there evidence that this could happen? Well, there's a new approach to using interventionist methods on trained up deep neural networks to try to uncover what representations they've acquired. And this is kind of informed by the best recent methods of philosophy of science from like Jim Woodward and other interventionists in causal explanation. The idea being that we take a trained up deep neural network and we intervene on its hidden layer activation patterns in a kind of direction that's hypothesized by our a theory of what that neural representation means. And then we see, does the change that we intervened on the system to make a kind of semantically meaningful change to that representation, does that have the predicted effect on output? And if it does, the thought is that's pretty strong evidence that that representation really means what you think it means. And you can apply this to those ideas about latent semantic social variables, right? So if we isolate a activation pattern in one of these networks, for example, that seems to be a good predictor of the communicative intentions of the person it's having a dialogue with, can we toggle or alter or edit that activation pattern so that it seems like the system has a different value for that variable, and then see, does it then produce behavior consistent with that? So I'll give you a couple quick examples. So one example of this interventionist method in practice is there's this very simple textual data set describing a bunch of chemistry operations called the alchemy data set. And they wondered, can it build an implicit world model of the chemicals and the beakers and the so on that are described in this chemistry set? So it's a bunch of experiments like, I pour 2 milliliters of chemical A in beaker 1 and 1 milliliter of chemical B in beaker 2, and then I pour the contents of beaker 2 in beaker 1 and it changes color to blue, right? And it's a bunch of experiments like that. Eventually it learns to predict the results of novel chemistry experiments that are consistent with like what the data set says about the properties of the chemicals in the beakers and so on. Now you wonder, okay, so in being able to predict the results of those chemistry experiments, does it build implicit world models of the chemicals in the beakers and so on? Well, you can develop a probe that isolates some subset of the model's activation patterns that are very good predictors of, say, the status of beaker 1. Is it empty or full? Then you can develop a method that takes, a similar probe to locate the status of beaker 2, and you can like copy paste by doing vector interpolation the status of beaker 2 onto beaker 1's vector representation, right? So if like beaker 1 is full and beaker 2 is empty, you can take the status of beaker 2 from its activation, interpolate it over onto beaker 1's vector representation. And now the thought is, if that's an implicit representation of beaker 1's status, the system should now act as though beaker 1 is empty when previously it was acting as though it was full. And that's in fact what they observed, at least for one of the large language models that they observed. So that's an example of an intervention method, right? There's no reason to think that would work on the basis of the training if it didn't learn implicit representations of these world models of the properties it's describing. There's other examples with like syntactic properties in linguistics. There's other examples of social semantic ones. But the idea here is I'm just trying to soften you up that these interventionist methods can give us some evidence that they do in fact have implicit representations of properties of the world and maybe could have representations for social intentions and communicative intentions with others. So it's not totally implausible. Okay. Probably better stop there. There are some attempts to make this a fully general method, right? So if you want to get further into this, there's this Stanford group that have developed a kind of general theory. So, suppose that you were doing this in a specific theory of social communication. What you would do is you might build like a causal model of what you think are the relevant variables in a successful social communication. That's over here with like what influences what. And then you have, you use probes to locate the closest thing to an implicit representation of all of those variables in the neural network. And then you do systematic, what they call interchange interventions, like that copy-paste editing I was talking about earlier, to then verify that your causal model is captured by the neural network, or in other words, that the causal model is a good description of what the neural network is actually doing. So there's attempts to make this fully general and even use it to scale in a big large language model like Alpaca. Okay, so that's it. So takeaways, empiricist philosophy of mind is a useful framework for evaluating progress in deep learning, but only if it's charitably allowed domain general faculties. According to the empiricist party line, much abstract knowledge comes from interaction with linguistic, formal, and social scaffolding. To some degree, this is already happening in the research, but we need even more ecologically valid curriculum learning. That is, like I talked about in the last 20 minutes or so, making the training of these networks even more maybe human-like and interactive if we want to get more human-like behavior. The empiricist thinks like that's where the important structure is. The next generation of AI will probably be even more dependent on interaction with human minds and social context. I gave you some examples, and probably the sky's the limit on how much more sophisticated this can get with reinforcement learning on human feedback, prompt engineering, turbo-powered social ratcheting, and more consistent, thorough representation of social and communicative intentions. Okay, thanks for your attention. And I didn't get into it in the talk at all, is that, like a lot of the big dualisms, sort of empiricist versus rationalist has just dozens of different incarnations, right? And so I try to distinguish, I think, at least 8 in chapter 1. And I try to say the only one I'm really focusing on here is this one about the origins of the mind's knowledge, right? And in particular, abstract knowledge. Does it come from experience, or does it come from unpacking an innate mental endowment? I do think that, you know, maybe the one that you're getting at is in epistemology is more a matter of evidence, right? Like, what is evidence for claims? And that's certainly, you know, been huge, maybe the primary inspiration for some of the incarnations of the rationalist empiricist debate, but it's not the one that I'm talking about here. I actually think the most central one is this one about the origins of knowledge, but like there's certainly a coherent, let's say, empiricist perspective, which, you know, maybe has an almost rationalist looking approach to evidence for knowledge, but still insists that all of the basic sources of information come from experience. Does that make sense? I think it would be a little unorthodox. The most natural fit, right, is you think it's sensory evidence that's justifying everything, and maybe you know, Carnap or whoever gets beat up on maybe thinking that you have sort of basic sense data that provide you with evidence. But you could certainly work it a different way. You could give up on that kind of basic evidence claim and still think, nevertheless, there's nothing innate built into the mind.
Okay, so maybe just staying on the same subject, in your takeaways, you seem to suggest that the empiricist model is basically the one that's more useful when you're trying to develop these types of models. But so what I don't understand is when you're contributing the database of the empiricist, there is a way to produce a model that has an increased approach.
Oh, absolutely, yeah.
And so what I was wondering is, can you not simply, I don't know if it's even useful to do it, but can you not create two different models that aim at doing the same thing?
Oh yeah.
Have they done it?
I think that's absolutely exactly what we should be doing.
And we've never done it.
Well, it's bigger than that, right? Because these things they're at such a high level of abstraction that you can't be like, here's the empiricist model and here's the rationalist model. It's more like we have lots of particular incarnations of these things that are maybe beholden to the particular technology and engineering know-how of the day. So like, you know, GoFi or classical AI, the kind of stuff that like Hoagland writes about a lot, that was all, I think, very much in this rationalist mode, right? Expert systems type approach to AI. For 30 years was the dominant view. That, you know, when I grew up, that was AI, right? Was you try to manually program all of the expert knowledge into the system. It just didn't work. Right? Just failure after failure after failure of the grand ambitions of this rationalist classical AI, because it was never flexible enough to adapt to new situations. You know, there's all the standard criticisms, or like you call it the toy world problem or blocks world problem, right? They were effective, but only if you like fully pre-digested the input for them and put it in the terms that their innate representations and rules could process. And that was the big limitation that prevented them from having very many practical applications. Because you might say it's like interacting with the world and its full complexity, and being able to abstract out from that full complexity the stuff that you really need to act on is the hard part. And that's why these vision models that I talked about were seen as such a breakthrough for AI. Something people didn't think would happen for at least another 50 years, was you could throw them full complexity natural data and they get the right label at it at human-like levels of accuracy, right? It was hard to believe even for me the first time I saw it. That was the point at which I was like, I've got to start working on this, because philosophers don't yet get what a big deal this is. Now, I think it's totally valid to say, yeah, but that was because of GPUs and because of, you know, our computational power. We have way more computation. I still don't like to say compute. That's the way they put it. Like, we have way more computational resources now. And maybe if the expert systems had that much at their disposal, they could do it. Here I want to just say, like, look, it's an empirical question. Do it, right? You know? I mean, LeCun says this to Gary Marcus all the time, right? If your ideas are right, show me. You know, where's the system? Here's the problem. Here's your rationalist. Show me the system that does this as well as my deep convolutional neural network. You know, it's ultimately an empirical question, and it's always possible that, you know, I think the most promising current incarnation of this stuff is like Bayesian models, where you're still often building in kind of high-level learning rules and sometimes a lot of innate representations, but then they're all fit to some data with Bayesian math. this is maybe the most promising incarnation. And it could be that they've turned some corner and, tomorrow all the engineers start using the most sophisticated Bayesian modeling. I don't know, it's an empirical question. But right now, the argument I make in the book is that the last 10 years, in my view, have kind of unambiguously increased the plausibility of the empiricist thesis as being the right, most productive way to go, both for philosophical purposes and for engineering purposes.
Marcus?
Well, thank you so much. This is great material. Looking forward to finally then reading the whole book. I have, two questions basically. One is, to which extent is this not, this strikes me as the least possible empiricist account, but rather as a wonderful defense of what I always thought rationalism was about, right? So everything that I heard, right? Has that been like a blank?
So like Locke and Hume were rationalists then, right?
Yeah, fine. But had you given me everything without the word empiricist, right? So you would have blocked empiricist, and now I'm ChatGPT, and I need to fill in, right, where this stands on the empiricist and rationals. I would say, oh yeah, cool, that's a really great representation of that. Plus, and now I think this gets a little more, to a certain extent, of course, it's not important where you stand, as you say, with respect to the grand dualisms, because I'm buying most of this regardless of, that tag. But then one thing where, which seems to maybe push some of this in the direction of the rationalist, etc. language, where they think they're strong, at least, right? Because you also don't want to operate against the strawman there. They think they're strong precisely because you don't need external input, but operations on the system in order to get somewhere. So one way of reading the AlphaZero revolution would be to say, oh, look, that's the a priori mind, right?
Yeah.
Hegel machine, as for instance, one guy at the Technical University of Munich calls it. Right? Babbage, for instance, which many people don't know, was very close to Hegelian logics for those reasons, right? So, where is and then this leads me to the second question, right? So, but it seems to be important, at least to some, if we bracket Berkeley as a problematic maybe development, but a story according to which the empiricist needs causal impact on the system, and that I don't see unless you build sensors into the picture for ChatGPT, right? I mean, of course, there's like in our abstract representation of what's going on, of course, you have input, right? But then the sense in which there's input for ChatGPT and the sense in which there's input to like a human animal, as in the Hume case, right? It seems to be very different. So then I would like to know, right? Maybe there's too much idealism built into ChatGPT, and then my empirical claim will be, okay, let's build sensors. The damn thing by really going empiricist. Where do you stand on that?
You might. Let me take the first question first. You might have to remind me to come back to the second one. But I get this reaction a lot, like, isn't that actually rationalism, right? I think this is the enduring legacy of so many people being raised on strawman interpretations of empiricism, especially Hume and especially the psychological behaviorists, right? So there's two huge areas of philosophy, especially in epistemology and metaphysics with respect to Hume and the logical positivists who later kind of like aggressively went after everybody else with a very staunch interpretation of Hume. And then in philosophy of mind, with like Chomsky and Fodor, going after, seeing that, they had to defend the legitimacy of their very existence in every public appearance against waves and waves of Skinnerian behaviorists, right? These social situations like push the most extreme interpretation of these views, which if you go back and read Hume, like it only takes a few minutes to realize like that wasn't his view. Or Locke, or any, and so my thought is psychological behaviorism and to some degree the logical positivists. Those were the historical aberration, and it was just the fact that they were so influential and so dogmatic at a particular point in the 20th century that so many people think like this is empiricism, right? Whereas if you look on a broader historical timescale, actually the much more plausible and historically supported view is what I call this moderate empiricism. So I call it moderate origin empiricism, and I still say that there's like this important distinction between rationalist perspectives, which is where you need something innate that's domain specific, usually concepts. So what you find again and again, if you look at Aristotle, Aquinas, Locke, Hume, James, right, all of the historical empiricists, the thing that they're really against is innate ideas. That's what they're against. It's not innate faculties or other kinds of transformation. Should I
No,
not get to the
ask
second
this
one?
question to try to come at it from an angle which I think will actually maybe get at what you're getting at. It's an unfair way to put it because you've just written a 488-page book on the history of empiricism, and I'm going to ask about the history of rationalism.
Okay.
So, but the question is, obviously one real opponent that self-identifies as rationalist in this, in the current context are the Fedorians.
Yeah.
So you have, so in that case, they're not going to agree at all with, the kind of view you're calling empiricist. They're going to say, bingo, that is our opponent. We disagree with you about that. They're not a domain general learning mechanism.
Well, maybe, right? I mean, so Fodor has this book called Hume Variations, which I think is and I talk about it a lot in chapter 4 or 5. This is me invoking the 500-page book. But in some ways, it's the most telling to me to figure out, like, how did we end up with this bad interpretation of empiricism? Because he has 2 chapters on Hume's theory of the imagination, which he thinks shouldn't exist if Hume was an empiricist. And he's like on record. And you can see him as he's writing the book being like, well, maybe, right? Okay, all right, actually, I better write a chapter. All right, I guess I better write 2 chapters about Hume's theory of the imagination, right? You can see him struggling with his former straw man interpretation of Hume. And by the end of it, he's like, yeah, okay, all right, maybe Hume was like right on almost everything.
But here's where I was going to go with it.
Fodor has these moments,
Yeah,
right?
no, true. But now I'm going to talk actually, what are the precursors in the history of rationalism to this opponent that is a very real, live, contemporary opponent?
Oh, yeah.
So where it's not about innate ideas.
Descartes and Leibniz.
Well, okay, but here's the Fodorian part that I think really, you're disagreeing with. It's modularity. It's,
Domain specific, at least.
in informationally encapsulated, domain specific, modules. That's that's where there's this real tension. And so the historical question is, before Chomsky and Fodor, what are the in the history of rationalism? Are there, and because this is the way of me asking Mark, if there's not rationalists
Are there Fodorian
before
modularists?
Chomsky and Fodor, then you could say, well, in the history of this, the kind of what you're calling rationalism didn't exist before 7 years ago.
The modularity point gets really delicate, right? And I have to put a bunch of text on this in the first couple chapters. So, like, my view is domain general and modular.
I know, but let's not fight about the word. Yeah, they're
so
using module.
What I mean by that is a very minimal notion of module, right? So Fodorian modules are domain specific and kind of like strictly informationally encapsulated. My modules are a little bit informationally encapsulated, but the really important bit is that each module has distinctive computational operations. So I think the right kind of modularity, the one that describes the brain and successful networks, is that you have different parts of, like, different structures that are dedicated to different domain general computational operations in virtue of having different stuff in them. And the thing that one domain general module is good at, like, helps you address the computational shortcomings of the other modules and vice versa. It's a kind of computational division of labor, but they're not domain specific and they're not strictly encapsulated. So you're right, there's a difference there. On the historical perspective, I mean, I do think on the innate idea stuff, there were like very staunch rationalists, and that's who Locke and Hume and James and had in mind. So, like, if you ask Leibniz what's in our innate idea of space, it's like all of Euclidean geometry, right? And you can get into subtle interpretation of what he really meant by that, but it seems like it was a lot, and it was pretty specific to geometry. Whereas the empiricists would say we get most of that from experience.
Do you have one on this?
It sounds like a question mark is a second question.
Yeah,
Before
I forget it.
Where are the impressions? I'm sure.
Tell me if there's one good question. But I take it like for empiricism, classically, and also in modern empiricism, what's crucial is not simply the idea that all knowledge derives from experience, which you can have an extremely rich conception.
Right, yeah.
It's that, and you hinted at this about it.
Exactly, yeah.
That they have a proprietary notion of experience, whereby from Hume onwards, they have a certain conception of, let's say, what is experience, what is observable, where crucially that falls short of the environment. That's where, if you like, empiricism becomes idealism. So then, one way of asking Marx's question is, well, in what sense here are we talking about experience when we're saying that when we're sort of training up these models or whatever. In one way, I can see that it is sort of deeply empiricist in the sense that it's not sort of world inclusive.
Yeah.
So in what sense would you say that, because so we're saying, empiricist philosophy provides a useful framework for evaluating progress in learning. Okay, so we say, what can they learn purely on the basis of experience?
Yeah.
In what sense is this experience?
Yeah, great. So I'm not sure I want to go along with the. I think this is getting back to two different. So here's the slogan: all knowledge comes from experience. There's two different ways of construing that. One is the epistemological way, right? In that the basic evidence or the basic data is experiential data, and that seems to fall short of the world. And there's all these worries about the sense data and whatever. I think the other one is this origin question that can be like an almost purely scientific way of thinking about it. It's about the causal origins of the stuff. And I think really for Hume, that was maybe even the more important one, was that the raw materials for representations had to come from sensory impressions, right? That's the sense in which I think the deep learning theorists are really involved, because they don't even have views on a lot of the epistemological questions that a philosopher is going to care about. But they insist that the basic data that goes into their model has to come from sensory impressions.
And that seems to be, in my interpretation, exactly what's going on in the expert model, and that revolution is one where you don't do that. So there's absolutely no representation,
right.
of the sense.
Yeah, all of the basic stuff of representations and expert systems comes from the program.
Exactly. Yeah. But that's an external environment. So my question is basically, right, where's the sensory dimension to this, right?
Yeah.
Hume, of course, has impressions, right? So where in your reconstruction, right?
So it's the basic inputs that go with it's pixel data. So in a deep convolutional network, it's pixel data. Now, large language models are a whole different debate, right? And so this is where a lot of the concerns about ungrounded. They had a great debate last semester in that philosophy of deep learning workshop on do they require grounding and so on. You can all watch those videos. But for what it's worth, like ChatGPT and a lot of the state-of-the-art ones are multimodal. So they're already building in, I don't think I have a picture ready, but I'll try to describe it really quickly. So one of the other coolest results that happened recently, God, what was the model's name? I'll just tell you the result. So ImageBind is what it was called. So I think it was Google Research. God, I hope I'm not getting that wrong with video. But one of the big research groups came up with a model called ImageBind that they trained on something like 7 different modalities. Okay, so auditory, visual, language. I forget what the other ones. It was from. Maybe it was Meta. It was Meta because they used the head-worn goggles, this Ego 4D data set. So it also had motion data and all kinds of stuff, right? And one of the things they were testing is if we linked each modality to another modality so that they were all kind of linked. So that in other words, you can pair sound and visual data, or you can compare the motion data to the visual data, whatever. Then it could spontaneously generalize from modalities that had never been paired in the training set but were linked to a common space. I think they used image space as the common space. So that suggests, right, that maybe the pressures of linking different forms of sensory modalities are not as bad as we always thought it was. Especially the rationalists, they always wanted to emphasize, there's this proprietary format of every sensory modality, and without the amodal representations to link them all together and language of thought structures or whatever, you'll never be able to get the kind of generalization. In the ImageBind, it's all just a vector similarity problem, right? Like once you transform every vector into a common similarity space, you can get like free generalizations to other modalities, which suggests to me that that problem in particular is not as hard as we thought it was. I don't know if that's assuages some of the doubt, but
that's very Gene? Thank you very much for this talk. It's absolutely phenomenal. I wanted to go back to your scaling, if you will, of historical figures, and perhaps propose an alternative to that.
You mean the continuum picture?
Yeah, which has to do with the notion of embodied recognition.
Uh-huh.
Because if we go back to Locke, we also have to remember that Locke was also trained as a physician.
Yeah.
And time again in the essay, we find that he talks about the purpose of knowledge for human being is preservation of the self as a totality, including its corporeal aspect.
Yeah, yeah.
And that's not something that I really readily identify with anything in the AI
Yeah,
space.
yeah.
And therefore, I wonder if one might take another look at Kant in terms of the idea of a finite rational being from which all form of corporeality is essentially abstracted, and to sort of see, granted there may be a problem with innate ideas and categories and so forth, but that Kant could also constitute an alternative that would not have this potential problem of dispensing with it by.
Yeah, Kant is another great example to bring into the mix here, because depending on how you read him, he might be seen as being agnostic on the origin question, but then insisting on a certain take on the epistemological questions, right? I'll say one thing, and then I'll go off on another spiel that you'll eventually see as relevant to your question, I hope. Have you followed the work of Richard Evans at DeepMind? So he was trained as a Kantian, and then DeepMind paid him to encode the principles of the critique into non-monotonic logic that's then integrated with.
Campbell Smith says at the beginning, if the critique had been written in Lisp.
Yeah. So Richard Evans is actually trying to do that. It's very cool stuff. I don't think it's the best solution, but it's definitely the best example of this type of work, and you'll probably find it really interesting. He's very sophisticated in his defense of it. But what I want to say with respect to embodiment and some of the other issues under your, maybe behind your question, is that if this were right, especially if like the self-preservation aspect and so on were really important to agency and intelligence and rationality, then you would expect these systems to be failing in certain systematic ways, or there are all kinds of things that they can't do. And the way I think this comes up is with developing an effective reinforcement value policy, right? So reinforcement learning has been behind a lot of the most successful examples of deep learning in the last 5 or 10 years. So like the Atari game playing systems or AlphaGo, AlphaZero, they're all reinforcement learning. They're trained on success or failure. But those are all very narrow domains where there's a very easy metric of success that you can use to craft a valuation function. In domains where it's harder to craft an evaluation function that's effective, ask an engineer. They will be very frank with you that it's black magic. It is just darkane, hack in the dark, and hope something works, right? One of the things I argue in particular in the last chapter of the book that's still missing from recent deep learning, but was absolutely essential to much of the empiricist story, especially in the early modern period, were the passions, okay? And the idea behind the passions, that they give you no account of how the basic passions are learned. You can learn all kinds of ways to channel the passions, and that's key to like Hume's ethics and theory of virtue and all the approaches to empathy and the way that the empiricists thought you got mature, moral, rule-like decision-making out of learning from experience was by channeling these passions and learning to like apply them with more impartiality and so on. That's almost still completely missing from deep learning. And I think what we really need is, and maybe this is the place where like current engineering methodology just can't help us, but like one of the things that evolution probably did was give us bodies. If you're a James Lang theorist of emotion or even sympathetic to it, you think that the body has a huge amount of influence, and not just influence, but like very rich source of all kinds of raw materials for experience and representation. Like, what is it to be hungry? What is it to be afraid? What is it to be in love? What is it to be bored or want attention? It's to have these certain signals generated by your body. And that's been tuned by just hundreds of millions of years of evolution, right? To be a source of, it's not just like raw reinforcement learning. I actually think current reinforcement learning algorithms are maybe a pretty good stab at the dopaminergic system, But the thought is there's all kinds of other neuromodulators and neurotransmitters that are influenced by the body in these very rich multidimensional ways. And just the stuff like boredom, curiosity, needing social attention, affection, all this stuff is going to be part of really getting a mature, rational, and especially moral agent, modeling those aspects in an artificial system, and we're barely even started. So the last chapter is kind of a call to do that research.
Great.
This is going to be redundant since you just asked my question about embodiment and self-preservation as a sort of model that's orthogonal to the empiricism debate. Maybe I just push it a little farther. Like you seem to answer that it's essentially an empirical question whether we're able to do this, the proof is in the pudding. I don't know, do you engage at all with like sort of almost a priori or transcendental argument that if you're modeling intelligence, then you're modeling rationality. Rationality is problem solving. Problem solving means norms and goals, and you can only get non-derived norms and goals from needing to maintain yourself and face threats and so forth. And I thought maybe you could just think about that in terms of either maybe push back on me, the Dan example, was really striking. What do you think about sort of an activist view that you just can't get there from here? It's not an empirical question, and how do you think Dan fits into it?
Yeah, I mean, I don't really have a way of rebutting the kind of Kantian transcendental attitude so much as I start from such a different starting point. The stuff that I really like, the stuff, if you're just asking like what I find decisive, is the really subtle commentary on Hume from like Annette Bayer and other Humeans, where the idea is that a lot of the empiricists, Hume maybe most interestingly, started with this rationalist idea of what reason is. He started by taking this notion of reason from like Descartes and the scholastic tradition, and where it was very much this, it would be at home in the transcendental approach to what rationality is and reason, right? And he starts acting like he needs to reject it. He starts thinking like he's got to say, no, we don't have anything like that. We should be skeptics. We should just treat us like animals and study what behavior we actually observe in everyday experience actually arises, and anything else is just habit or whatever. But as you get deeper and deeper into Hume's works, you see that actually he starts reinterpreting reason as he goes through it, where reason now is a kind of habit that passes its own test kind of thing. So it's reflective, and it's got all the faculties operating on it. You're imagining different possibilities, and you're reflecting on your previous behavior, and does it meet the standard described in language that you previously committed yourself to? And you start to get a lot of the stuff back that was associated with the rationalist approach to reason. But now it's not based on like the fact of reason or any kind of Kantian starting point that you have to just kind of take or leave. It's rather based on an etiological story, a kind of personal development story about how you reach that kind of thing from what comes before. And the Humean thought would be like, if you can have all that without a basic assumption of a starting point that's just like different from everything else, then why not do it that way? And I'm swayed by that, but I get the transcendental argument.
Taylor?
Thank you for your talk. It's super interesting. And I was really interested, especially in the part where you're talking about the idea that what's distinctively human is that we have cultural accumulation of knowledge over time, and that we achieve that through deference to knowing the past. And you were arguing that might not be so distinctively human because that's also learned how large language models learn too, right?
Well, it was an open question whether or not we can actually get them to do that, right? Well, there's two kinds of deference, okay? So we want to keep the two kinds of deference separate. So the Putnam style deference, his point was like, he asked the question, could people refer to water in the 16th century before they knew it was H2O? So maybe today we think that like H2O is the common microstructure to all examples of water, but they didn't know that. And nobody in their civilization knew that. Maybe they thought water was a basic element. And so the question is, do they mean the same thing by water that we do, or was there like a radical term change? And it's just a coincidence that we use WATER, a kind of historical accident. And Putnam says no. Actually, they meant to be referring to our water. And that's why they see the discovery that water is H2O as a discovery and not a subject change, is because H2O explains all the surface properties that they associated with water. So the way Putnam says what you should learn from that is that, at least for natural kind terms like water, they all involve a kind of deference to future discoveries. Okay, now that's separate from the kind of deference in the Tomasello ratcheting hypothesis, right? That's the deference to previous generations, where you're learning from a teacher or a conspecific or whoever, that you sort of assume they know what they're doing, and you're really attending to what they're doing, and you're trying to attend to what they intend you to do. Sorry, that's kind of auditorily confusing, but you get what I mean, right? So you're deferring them by devoting certain imitation and attention resources to them, because you want to learn to acquire the competency that they have in a very efficient, quick way. And that maybe involves some special adaptations, like chimpanzees are bad at it, for example, maybe because they're too competitive, is Tomasello's hypothesis. It's that chimpanzees are naturally competitive, and that kind of like interferes with their ability to learn by imitation.
Okay, so
So does that help?
you think that maybe the second kind of deference is possible, or?
Yeah,
Yes, so my.
but maybe we need some more tweaks.
Okay, so my question is, if that kind, okay, so, it seems like that kind of deference is how we learn as children, right?
Right.
We learn from
Yep.
assuming that what we're told is true.
Right.
And that part of maturation is learning that the things that we've been told might not be true, and being able to distinguish between better and worse views. And I wonder if you think that if a large language model that's built on learning for deference and for second kind, if you think that they're capable of making judgments at that level and seem more distinctively
Yeah.
than
Yeah.
the initial
Great.
child.
Yeah, great. So this stuff even kind of intersects with the last question. So partly what I was getting at with this Humean view of reason kind of being reinterpreted is the empiricist's answer to this is this reflective equilibrium over long periods of time. And I definitely don't think large language models do that yet. So that's a very good thing to start aiming for, is like a large language model that could do reflective equilibrium, but it would absolutely implicate the faculties essentially, right? So what is reflective equilibrium? I need to be able to formulate the principles that I think I'm following at some point. And the empiricist is like super skeptical about introspection. This is, one of the most important threads for me, is that like introspection sucks. And it's not a reliable source of information. And we always try to make ourselves out to be smarter and so on. I've written a lot about this in the past under the heading of a bias I call anthropofabulation, which is a combination of anthropocentrism and confabulation. And I think that's a lot of what motivated the rationalists, was they introspect and they think, man, I'm so smart. Look at how great I am at doing these things. But you're actually, lots and lots of social science has suggested that we really don't know how we solve problems. We're not very accurate. At least, so there's a particular kind called protocol analysis, where you speak aloud while you're doing a task, right? And that's pretty reliable, at least of the stuff that you're attending to or representing at a time. But if you do a task and I ask you 1 minute or 5 minutes later, you're like, it's just no causal connection between the stuff that you say and what actually produced your behavior, right? You tend to produce justifications or explanations that like make you look smart and impartial and get you out of trouble and that kind of stuff. So the thought would be, it's not introspective evidence that's somehow like infallible, that's driving our ability to be rational the way some rationalists seem to think. It's rather our ability to formulate the principles that we, as like a hypothesis of what was producing or driving our behavior, and then hold ourselves to that in the future, right? So like if I say, this is the principle I'm trying to act on right now, maybe I thought that's what I was doing. Who knows what I was actually acting on in the past? But now that I've formulated my principle, I can now monitor whether my future behavior or reasoning or decision-making or whatever is consistent with that, and continually try to reduce the gap between my actual behavior and the principle that I think I should be or want to follow. And that's the evolution of moral and psychological development that most empiricists will offer you, especially the sentimentalists. So that's why Sophie de Grouchy, who's a fantastic empiricist philosopher who hasn't gotten nearly enough attention, She was a translator of Adam Smith and then wrote this long commentary on his theory of moral sentiments, where she exactly talks about how you abstract mature moral decision making with what we would now call a long process of reflective equilibrium by continually seeing what principle am I trying to follow, also a lot of social input from caregivers and peers. How do they view my behavior and my stated principles? And how can I calibrate that all to be like more globally consistent? And she thinks the natural outcome for that for someone who's appropriately attentive is like abstract, fair moral principles, the same type of endpoint that like a rationalist would end up at, but you get it through a very different route.
Quick.
Sorry, I was just gonna say though, one of the things that seems to be distinctive with human too is that we care about the knowledge
Yes.
we have.
Yes.
And so if you're starting with a starting point, and then you extrapolate the principles and you see if the future instances are consistent with those or not, like that's still starting with an assumption. And the question is whether you can, achieve something new because you care about the results.
I don't know. That's a really interesting question. So caring about consistency or caring about social approval? I think a lot of empiricists would think maybe you start out caring about social approval. In fact, one of the reasons I think I like Sophie de Grouchy, her fundamental departure from Smith was she thinks Smith didn't go early enough. So Smith thought the basic source of evidence for this bootstrapping process was the approval of others. And Sophie de Grouchy, who was a mother, thought it starts like in the crib from the very first moments of dependency on others. Like you start to care about others because you care what happens to the caregiver or mother or whoever is giving you food and cuddles and stuff before you even draw a distinction between yourself and them. That's one of the brilliant ideas that is in Sophie de Grouchy, is like you've always thought there was this gulf between self and other that needed to be closed by reasoning. That's certainly the way many rationalists come, is like you start out this solipsistic egoist, right? And you have to somehow cross the Rubicon to be like, oh yeah, others matter too. And Sophie de Grouchy's like, that's not how babies work, right? Like, have you ever raised a baby? The babies care about what happens to you, and they get, they just start out caring about you because their livelihood depends on you, and yours on them to a certain degree, right? Now, do we start out caring about consistency? I doubt it on the basis of raising 2 kids myself, right? Like, you have to really be like, look, just a second ago you said this, and now you say this, and they're like, that's the way it is. It takes like, maybe by age 10, they start to care about consistency, only a little bit, but that's a big cognitive achievement.
This all speaks to our view that the apperception you're describing is like constitutively dependent on these basic life conditions. Care and the will of mother, daughter, survival. So that's where you're at. Whereas like the fundamental care that I'm getting wrong, what I've now stated is my principle that I'm operating on. It has to be grounded in some sort of fundamental orientation towards better and worse.
Well, we might have to talk more. I've never heard this like early developmental interpretation of apperception.
Video.
Yeah, thank you so much for your talk. This is fascinating. I'll try to be brief, but unfortunately I want to press the cons question.
Okay.
Because it seems to me that there are clear advantages to adopting a straightforward Kantian model that go beyond just liking a transcendental way of thinking. So to me, the 2 clear advantages that I'm seeing of programming from the perspective of Kant would be first, minimalism about faculties, right? You've just got sensibility, the understanding, and if you're Heidegger, the imagination. And I'll say more about why I think that minimalism might be desirable in a moment. But then also, right, and perhaps most importantly, the structure of mind for Kant is a necessary and sufficient condition for a robust system of morality, right, and of political community. And to me, this seems really important because if you're Richard Evans, right, you made a Star Trek reference, so I feel like I'm allowed to say this, you'll end up programming data rather than lore, right? Because if you've got Kant's system, the entire reinforcement learning problem that you were illustrating in Dan just goes away, right? It's not possible to make the system do terrible things because there's just they're not motivated by external punishment and reward if the system is Kantian, right? And one of your answers earlier seems to indicate, you're saying, well, that's just not how the mind works. We have a dopaminergic system, right? And so we are motivated by punishment and reward. But I suppose my response to that is, just because we are embodied in that particular way doesn't strike me that an artificially intelligent system needs to have a dopaminergic system, right? Needs to have a punishment reward. So those seem to me to be pretty strong reasons for starting from Kant rather than Hume. And so I'm still wondering.
Yeah, that's a really interesting way of spinning what's going on here, right? So, I would say, like, we do have a lot of Dans in humanity, right? So if our goal was to model how the human mind works, then it seems like we should go this empiricist way. But you can, and this comes up all the time in engineering. It's like, well, what if we don't care how the human mind actually works? I mean, I've always thought like a great way of viewing what Kant gives us is like the ideal, right? The ideal that maybe no human ever realizes. And it always gets very frustrating to me, at least when I was reading Kant as a grad student, to be like, but so I can never be really moral if I don't act purely from the goodwill, and that gets very frustrating, right? But if you say, like, we're now engineering beings, like maybe we should engineer beings that are better than us, and we don't care whether humans never reach the ideal. Maybe can we create a being that actually reaches the ideal? It's an empirical question. I would be maybe totally on board. There's a lot of science fiction about like how trying to do that leads to problems, right? But if you give me the system that maybe doesn't have reinforcement learning but can still do the stuff we do with full flexibility, I'm all on board. I'm going to buy one for the home, right? Whatever. Let's do it.
Yeah, that's exactly why minimalism about faculties might be really great, because if you don't have the passions, right, you completely avoid the Wille Willkür issue that is what makes Kant feel so impossible.
Yeah. I mean, I think the empiricists think that there's no way you could get a system that had the flexibility of human moral and social interactions without the passions, but could be wrong. That's part of the empirical reframing. Like, it's a contest. Let's see. Build a system. See, maybe Richard will have it in a couple years.
I don't know your name, sorry. That's a good question.
Me?
Yeah.
Oh yeah, thank you. I'm Violet. I had mentioned William James.
Yeah.
In relation to attention.
Yeah.
I have a question about this. So I feel that William James's empirically aligned pragmatism assumes a desire and a need to know, but a great love for the inability to know. So like a love for the lack of an answer and a love of abstraction as almost like a core aspect of human consciousness. So maybe this question is like too abstract, but like how could this be applied to AI learning, and could an AI love its own inability to know, its own inability to provide an answer?
I'll talk about something that I have views on and see if it is in the neighborhood. So one of the things that's obviously present in a lot of biological systems, but missing in a lot of artificial systems, is so let me go back a little bit. So I did a lot of animal cognition in the past, and I studied ravens, which are very neophobic. And in the same lab, they also had Kias, kind of New Zealand parrot, which are super neophilic. So ravens are immediately afraid of everything new. And they look at it really skeptically, and then like the head raven will have one of his henchmen go like peck at it and see what happens. And then maybe like 2 hours later they might start interacting with it. Whereas the Kias, as soon as you put something new in their enclosure, they're like playtime. They're like these climb all over it and try to pull it apart. And these are like attributes of individuals that have clear consequences to their cognition that are based in biological differences. And I think we should really be thinking about these other aspects. It can have consequences for decision making, like the structure of decision making, exploration of an agent and an environment, also learning rates. So like another bit of dark magic in a lot of deep learning, machine learning, is like, what's the right rate at which I adjust representations in light of new data? And there's a lot of different methods. There's like simulated annealing and early stopping and critical periods, and this is another thing. So like every time a rationalist hears like, oh, I had to build a critical period of learning into my system, they're like, aha, innate domain specific. And I want to say like, no, right? That's just changing the learning rate. Like curiosity, for example. You could have this, we know pretty good about how a lot of this brain system works. There's this system called the cholinergic modulation system, where every time our predictive learning gets like a really unexpected result, so like you see something surprising, your cortical tissues and hippocampus get flooded with this modulator called acetylcholine. And that increases the plasticity of the relevant tissues, and other hormones increase alertness. So like suddenly you're now like really paying attention to whatever the new thing is, and you're getting very rapid learning. And we already know when we build this method into some models, we can get more effective learning. And if it's got a good fit with the informational structure of the environment, that is where there's occasional surprising things where you don't have a lot of opportunity to interact with them, being able to tweak the learning rate short term, and then as the acetylcholine floods out or you gradually lower the learning rate, you go back to kind of more gradual long-term storage, can be a very adaptive thing. And so this is a prime example of where I think there's still a lot of benefits to be gained by looking at what evolution has done to structure the more subtle aspects of hormones and neuromodulators in response to different learning outcomes in the environment to tweak learning, but crucially in a domain general way. Right? Yes, it's innate, but that doesn't mean it's rationalist, because you can learn on almost any topic in that way. Surprise is not limited to social or physical or whatever.
On that note, thank you so much.
Thank you.